Okay, so we will start today with topic 6, okay? And I won't really teach everything about that. So we will only go through question. And in the question, if you come across exercises and if you come across the video and your notes, good afternoon, by the way. Lupa. So I think that words that you always come across is the word equilibrium in the entire chapter. Okay, so there is 2 things that you need to know about equilibrium. Anyone? When you mention the word equilibrium, what should come into your mind? All right. Concentration of the reactant and the concentration of the product shall remain the same. When you achieve equilibrium at the end of the day, when you have something balanced. Saya guna perkataan balance dan saya tak guna perkataan sama. Alright, pernah main jongkan-jongkit? Kamu hanya perlu balance tapi kamu tak perlu sama. Kalau saya ada seorang yang 100 kilo duduk kat sebelah, saya tak perlu ada seorang yang 100 kilo. Saya boleh ada 3 orang yang jumlah berat dia 100 kilo. Betul? Saya perlu keseimbangan. Saya tak perlu persamaan. Okay? They need to be balanced but they're not necessary to be the same. And the most important thing is when you reach equilibrium, the concentration of the product, sorry, bukan sama. Correction a bit. The concentration of the product and the concentration of the reactant shall remain unchanged. Dia tak perlu sama tapi dia takkan berubah dah. Kenapa dia takkan berubah? Because when you achieve equilibrium, next question, is your reaction stopped? No. Alright? The reaction doesn't stop. Bear that in mind. Bila kita kata dia achieve equilibrium, none of the reaction stop. Reaction kamu tak berhenti. Sebab dia two-way. Alright? Whenever we talk about equilibrium, it's always two-way. Tengok screen tak ya? Tengok saya. Jangan excited sangat weh. Alright. They are always two-way. Dan bila reaction tu kita kata dia capai equilibrium, dia takkan berhenti. Alright? Sebab dia dua hala. Apa yang kita kata sama, apa yang kita capai seimbang adalah jumlah daripada reactant jadi produk dengan produk jadi reactant sama. Betul? Kalau saya ada sebiji reactant jadi produk, kita akan ada produk yang jadi balik reactant tu. Sebab tu kita nampak macam dah berhenti. Kita nampak mata kasar macam dah berhenti. Tapi in fact, dia tak berhenti. Okay? So the second thing that you need to know, reaction does not stop. Okay? The reaction does not stop, but the rate of reaction forward, the rate forward akan sama dengan the rate reverse. Okay? Yang tu yang kamu kena tahu pasal equilibrium, and that is the only thing that you need to know about equilibrium. Okay? And of course, the next thing that come into your equilibrium adalah your formula. We have a few things that we need to learn. Dalam soalan kita akan bincang. I believe KCKP ada masalah. Boleh tulis formula dia? Formula dia? Tak payah tekan mic dah, boleh cakap je. Product? Product to the power of coefficient over? So selama ni adalah masalah mic nak tekan tu lah. Kalau tak payah buka mic, hampa tahu je nak jawab soalan. Okay, now I know. So KCKP tak ada issue, product of the coefficient versus the reactant over the coefficient. So sebelum ada KCKP, I think the most important thing is your balance equation. And everybody should know from the video and the notes, KC kita hanya ambil kira gas dengan aqueous. KP kita hanya ambil kira easy peasy. Okay? Simple. Yang tu kita akan tengok. Dan hari ini juga kita akan tengok the relationship between your KP equals to KC, RT delta N. Kita akan tengok yang tu. Kita juga akan guna ice table. Alright. Saya rasa kita akan sempat masuk sampai ice table hari ini. And then ada 2 benda last yang kita akan tengok. Yang ni tak ada dalam video. Kita akan tengok degree of dissociation. Video je tak ada, nota ada. Senang. Senang sangat sebab tu saya malas nak buat video. Okay. Degree of dissociation. And last but not least, I think tomorrow we'll be going into quotient. Okay. Yang tu pun senang, tak ada issue. Question? And I think the biggest problem in this chapter is when you read the question, alright, when you read the question, sama juga yang kat rumah, when you read the question, I think the biggest problem right now is kita ada value yang kamu kena tahu dia duduk di mana. Before this, in all this chapter, you only need to know value ni siapa punya. Betul? Alright, value ni siapa punya. Tapi kat sini, kita kena tahu value tu sekarang duduk pada initial, value tu duduk pada change, ataupun value tu duduk pada equilibrium. So, we not only need to know dia adalah siapa punya, kita kena tahu dia duduk di mana. Okay? And ada masalah nak tentukan soalan I-stable dengan tak ada I-stable, bila masa nak guna I-stable? Okay ke? Kalau siapa yang tengok video betul-betul bukan pakai tengok makan popcorn, tengok Netflix tu, dia akan okay lah. Okay? You know, sometimes you can watch the video like watching Netflix. Okay? And I'll be very proud. Okay? I'm impressed. Alright? I'm impressed kalau budak boleh tengok video saya kat cafe tapi tak pegang pen, tak pegang apa. Aku macam, you only miss out popcorn. You know? Okay, yeah. I need to supply that maybe. So, we will go for question straight away. Your exercise 6.2.1. Kita buat by stage, kita bincang soalan 1 hingga 10 dulu. From the question 1 to 10, any problem? Yang duduk kat rumah, soalan mana yang tak boleh buat? 1 to 10. We look at 1 to 10 first.
5, Miss.
Mimi?
5, nombor 5. Tak dengar.
Mimi saya tak dengar, saya tak pasti sebab 1 second. Mimi try again. 5.
Nombor
Mimi
5.
kata 5. Yeah, just now it connected automatically to the projector speaker. Sorry. Anybody can just say something? TV, can you hear me loud and clear?
Hi, Miss.
Hi, Miss. What a something. Thank you. Well, at least she said something, man. Sebab ada soalan yang sangat senang. Okay, so kita tak bincang lah soalan 5 apa benda ni. And then experiment 1 more SO2 contain Saya tak tahu kenapa dia nak buang langsir. Kenapa? Tak tahu. Okay. Alright, can we go through this question very quickly? Ani will be having heart attack like every single minute. Are you okay or you want to move? I'm not there to move. Okay, just very quickly. Sorry. I need to speak quite loud. If not, your friend cannot hear me. Just keep getting shocked lah, then you won't be fall asleep. You know? So, question 5 over here we have an experiment. 1 mole of SO3 is introduced alone into a 2-liter container at 473 Kelvin. The reaction is as follows. So, dalam soalan chapter 6 for me, soalan level rendah sikit adalah soalan yang dah datang dengan chemical equation. Soalan chapter 6, sebab chemical equation akan jadi orang yang paling penting. Nak tulis KC, KP bergantung kat dia. Nak buat I-stable bergantung kat dia. Kalau equation kamu dah salah dari awal, you're pretty much gone. Okay? Sebab KC dah salah, I-stable semua change, kamu dah salah. So untuk saya soalan chapter 6 kamu kena doakan satu benda. Bukan doa soalan senang. Doakan soalan chapter 6 keluar dengan chemical equation. Alright? So, kalau dia dah bagi chemical equation, that is quite simple and straightforward. Whenever you have the chemical equation, check one thing, the physical phase. Make sure dia adalah benda yang kita boleh guna. Dan disebabkan gas adalah satu-satunya physical phase yang kita boleh guna dalam semua. Dan perasan tak soalan selalu gas? It's not because I want to make your life good. No. Because dalam reversible reaction, most of the reversible reaction adalah gas. Sebab gas boleh pecah dan gabung dengan senang. Solid kalau dia dah cair, kita kadang-kadang solid yang dah cair tu dia takkan jadi balik solid tu. Sebab tu dia selalu ada gas. It's definitely not because I want to make your life easy. I wish to make it as hard as I can. You always remember that, don't you? Okay, so it just kebetulan lah. So over here, soalan pertama, of course, 1 mole given over here, initial change or equilibrium. Initial. If you read the question, in an experiment, blah, 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 introduce alone. The word introduce, the word insert, the word place, it's only 10 minutes ago. You want to change place with Ani? What dah? It's only 10 minutes, lady. Where we are? Introduce, inserted, place, started with, at the beginning, time 0, semua tu adalah initial. Okay, so yang ni adalah initial, and then the reaction as follow. When equilibrium is established, 0.152 mole SO3, 0. blah 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 are present. soalan saya, number of mole yang diberi di bawah adalah number of mole pada equilibrium. Read the question very, very carefully. That's it. Kita tak pernah ada keadaan di mana kita kena teka. Always remember, the moment kamu rasa kamu kena teka, ladies and gentlemen, you are wrong. Do it again. Okay, kita tak ada teka-teki kat sini ya. So, everything over here adalah pada equilibrium. By the way, hang kutuk aku dengan Madam Sasa ya. Lagi aku nak tanya soalan kat hang. Tak ada? Tipu. Okay. Alright, saya combine dengan Madam Sasa by the way. Okay, over here, the first question. I want to calculate the initial concentration of the reactant and product. I think that is pretty simple. Kita buat, semua ada soalan kan? So I make it smaller ya. Alright, let's take the question with you. Hang tutup aku. Jaga. Okay, dalam exam nanti, dalam exam tak kisah objektif ke subjektif objektif lah sekarang obviously betul. So dalam objektif nanti, walaupun dia adalah soalan objektif, guys, keluarkan data dan label. Especially soalan macam ni di mana kamu ada number of mole initial, label cara paling senang. Jangan tulis panjang-panjang. Ni cara kita label initial. Cara label untuk equilibrium, number of mole equilibrium, siapa punya? Saya ada SO3, 0.15. Keluarkan. Tak payah baca soalan tu 2000 kali. And label very clearly, dia adalah siapa punya dan dia adalah pada keadaan apa. That is how we label the number of mole equilibrium, number of mole equilibrium of SO2. Easiest way ever. Kalau number of mole kita guna N kecil lah, betul? Kalau concentration, kita guna concentration initial, concentration equilibrium. Kalau pressure, kita guna partial pressure initial, partial pressure equilibrium. Saya tahu dia banyak value nak label. So saya tak nak kamu tulis panjang-panjang. Tapi saya nak kamu label. This is the shortest that we can use. Okay? Tak payah tulis ayat panjang sayang. Tak dapat markah label tu. But you need to know the label. So, soalan paling senang A. I want the initial concentration of each reactant. How can I get the initial concentration of each reactant? Mole bahagi volume. So, concentration initial yang saya boleh cari pertama adalah SO3. Look at the way that I label, ladies and gentlemen. Look at it. So, I have the SO3 initial concentration. Datang daripada number of mole initial. Sebab tu kawan kamu kata, kawan-kawan kamu semua kata 1 mole over 2 liter. Adakah saya perlu explain kenapa? Mole per liter. Happy with that? The problem is for each reactant and product. Concentration initial product. Kenapa? Sebab reaction have not started. Product belum terhasil. Mak kamu nak buat kek, baru campur telur dengan tepung, tak bakar lagi. Ada kek? Alright? Betul kan? Why do I look like clown to you? Hang gelak je. Oh, sonok sangat yang ni. Hang tak kena marah lagi. Look at the first statement Human give to me. This one jangan marah tau. That is my reputation in your heart. So bad. All right. Next question. By the way, any problem? Talking about this Y0. Yang tak balik tu, adakah anda rasa menyesal? Let us look at their face. All right. Adakah anda jealous? Sila. You can see me real. Finally. All right. In skin, in touch. I'm a person, by the way. Where we are? B. Okay. Looking at your B over here, I need to bring my iPad tomorrow so that I can see that. Just very insecure when I cannot see you, you know. All right. That's how much I don't trust you, by the way. All right. The next question. Tak sukanya bila aku tak nampak. Calculate the concentration of each reactant and product at equilibrium. That is quite easy and straightforward soalan ni. Sebab dia dah bagi semua number of mole equilibrium. Betul? Dan volume saya pun sangat senang. Volume saya straight away adalah 2 liter over here. Soalan yang senang. Saya pun tak tahu kenapa saya bagi soalan senang macam ni. So you have your concentration of SO3. Sorry. Yang ni tak ajar kot. Saya bagi jawapan je lah. SO3 equilibrium, I think 0.152 divided by 2. 0.071. 0. Oh, betul-betul. 2 bagi 2. Betul. 7. Sorry. Petang dah, tak pandai congak dah. Macam biasa tak ada jawapan. Saya aku pergi cari jawapan saya. Your oxygen 0.414 divided by 2, therefore you are having 0.207. Perfect. And then you have your another one, tak ada tempat. So let's see, I have a SO2 equilibrium. Look at the way that we label, 0.814 divided by 2, therefore you're having 0.424. Agree? Perfect. Yang ni ada masalah? Dan masalah next adalah C. Betul? How to sketch. Before we go for how to sketch, can I just take a quick look on how you sketch? First and foremost, we need an axis. I thought you're not coming. Apa dia? Aku tak dengar apa sebenarnya dia cakap. Aku baca tu. Tak ada apa. It's fine. She's fine right now. She's breathing and she's here. Good. Okay, that's it. Tak payah tahu kenapa. Okay, talking about the curve. Macam biasa, mungkin kamu rasa tak penting sebab kamu tak perlu lukis bahawa it's an objective. Tapi bila it's an objective, soalan boleh keluar dan suruh kamu pilih curve sebagai jawapan A, B, C, D. So, kamu boleh tak lukis, tapi kamu kena faham apa lukisan tu. Okay, we target the objective right now. You know what's the difference between objective and subjective? Subjective, you need to improve and you need to be good. And I can make you improve, I can make you so good. I believe I have somehow made you better. Okay? But in objective, I need to make you to have no mistake. I can make you million times better and I believe I have somehow did it. But how can I make you having no mistake at all? Any idea? Hantarkan kalkulator darat dua pun salah weh. What can I do? It makes me so stressed over these few weeks. How can I make you have no mistake? I can make my students so great. But we're human beings, you know? And how can I make my student having no mistake, zero mistake, because we don't have that tolerance. Kamu tak boleh salah satu tempat, satu titik pun. Is there any formula? Okay, axis, first thing as always. Benda yang kamu kena label kat sini adalah axis Y yang mesti kena ada unit. Axis X adalah time, tapi time tak wajib ada unit at this moment. Selalunya adalah second, tapi selagi soalan tak bagi tahu dan kita tak payah label. Tak payah lukis dulu, yang ni dengar dulu. Next, when you already have the axis, the next thing that you should have before you draw is a line. Okay, a line that having a constant time. And this line is what we call time at equilibrium. Bear that in mind, it's not the graph, it's part of the graph. So dia adalah dotted line. And this line is a time, that particular time where everything achieve equilibrium. Do we agree that when you have reactant and product that everybody will achieve equilibrium at the same time? Betul. Bila dia kata rate of the forward sama dengan rate of the backward. Bila dia dah sama, dia kena sama pada masa yang sama. Betul? Ini adalah masa yang sama tu. Okay? And everybody knows that reactant akan turun. So, reactant mesti akan start pada tempat yang tinggi dan turun ke tempat yang bawah. Right? Next question. Adakah dia akan sentuh kosong? Tak. Dia takkan habis. That is the beauty of equilibrium. Bila dia lain dengan limiting. Limiting dia one way. Dia kena habis. Betul? Equilibrium dia reverse. Dia takkan habis, kawan ni dah hasilkan dia dah. So dia takkan sentuh kosong tapi dia kena turun. So let's say my reactant turun. Merah kita adalah reactant. Saya turun. Dan selepas line ini, selepas dia sentuh, dia turun, dia sentuh kat time equilibrium, you are going to use your ruler. Semua yang saya kata line lurus adalah pembaris terus. Kamu akan ambil pembaris, kamu akan tulis, lukis terus straight line. a solid straight line straight away. Okay, let us choose the same color. You know, I cannot draw straight line, so I'll show you this. My question, kenapa right after the time equilibrium, graph dia adalah flat? Anyone?
Concentration remain constant.
Thank you, Banjit. Concentration remain constant after the equilibrium. Betul? So, where we are? Okay. That is the reason why we need that time at equilibrium. You need the time at equilibrium, and right after the time, your curve yang tadi turun tu mesti kena jadi flat. When I say mesti, kamu kena guna pembaris dan dia kena constant. That is your reactant. So kita akan label reactant kamu lah, whatever reactant yang kamu ada kat situ. Okay? And then kamu akan label your product. You know that product kamu akan naik. Betul? Dan produk tak semestinya naik daripada kosong, tapi selalunya dia akan bermula pada kosong. Seperti yang kita bincang tadi, initial concentration produk adalah kosong sebab tak ada lagi. Right? So dia naiklah daripada kosong, dia naik. So katakan dia naik. Dan look at it. Dia akan naik sehingga kat time equilibrium. Dia akan naik sehingga kat time equilibrium and then dia jadi flat. Aku cakap aku tak boleh lukis flat. Hampa assume dia flat. Hampa assume dia flat. Quite flat, yeah. So that is my product. And why is it important to have the time at equilibrium first? Because we agree just now they must achieve equilibrium at the same time. Bayangkan kalau kamu lukis graf ni tadi dari awal, kamu lukis graf ni, tapi kamu tak ada time equilibrium and saya suruh lukis macam ni, freehand. Hang rasa dia akan jadi flat pada masa yang sama tak? Alright, yang tu dulu kalau kamu kena lukis. Sekarang bila dalam objektif kamu kena pilih jawapan lukisan tu kalau dia keluar, betul? So syarat dia, everybody need to be flat at the same time. Betul? The concept of equilibrium, dia kena capai equilibrium pada masa yang sama. Pertama. Kedua, selepas time equilibrium, bila kita dah capai equilibrium, the curve need to be flat. Sebab the concentration will remain unchanged. See that? Okay. And yang dua yang saya rasa agak confusing lah. Yang ketiga adalah dalam exam dia mungkin takkan label. Saya label sebab saya nak bagi tahu dia adalah reactant, dia adalah produk. Dalam exam kalau dia tak label, kamu kena tahu yang turun adalah apa, yang naik adalah apa. Bear that in mind, in a normal reaction, produk kena bertambah, reactant kena berkurang. Nampak? Okay. So that is the basic of a curve if you need to find the answer. So over here, what makes it different is kita ada data. Dan bila dia ada data, ada satu benda, data kena masuk dalam tu. Bila dia ada data, kamu tak perlu skala sebab dia hanya sketch, tapi dia kena logic. Logic maksud saya kalau saya ada 0.2, logic tak 0.1 kamu duduk atas. Itu logic saya lah. Dia tak perlu ada skala yang betul, tapi dia kena logic lah, betul. So, starting off, yang ni boleh buat sama-sama. We starting off with the axis. That you have your concentration. That you have your time. Sama, we will start off straight away with your time at equilibrium. So, I will have my time at equilibrium. My line never straight. That's fine, you know, never straight. Sebab betul aku nak lukis ni. Okay, agree? So that is our time at equilibrium, easy peasy, senang. Alright, logic. Nak pilih jawapan macam mana, nak tengok skala macam mana, tengok value yang paling besar atas value yang kita nak lukis. We have a few value yang kita nak masukkan dalam tu. Semua initial kena masuk. Semua equilibrium kena masuk. Betul. This is the 6 value that need to be in that. Alright, when you're not online and you don't have name on your picture, I don't even know your name. The only person I remember, Human, Zawanis, and that's it. Ani, yeah. Alright. Well, sebab dia tak pakai tudung, cuba kalau dia pakai tudung, aku minta jam dah. So it's actually quite lucky to be back sebab saya tak recognize. Alright. Yang saya recognize tak balik TV, benzin, yang tu saya dia pakai mask ke pakai apa pun saya boleh cam. Shikin tadi saya cam dah awal lagi. Saya dah sembang dia dah sebelum pemain dia main awal weh. Wah kami macam ni lah weh hang. Okay. Si hang macam ni kuat lagi ke aku dengan dia macam ni kuat lagi? Ha. Baik ya. Skala. Macam ni habis tak ajar. Alright. Okay. We need a logic value. So when you need a logic value on a graph that you are not having scale, the easiest way adalah tengok value yang paling besar dulu. Value yang paling besar kita ada 0.5. Sebab saya ada 0.5, 0, 0, 0.076, 0.2, 0.4. Kenapa saya kata value yang paling besar? Sebab paling kecil mesti kosong. Paling besar letak ke atas siap-siap. So kamu boleh nampak dah. Paksi Y saya hanya perlu bergerak daripada 0 hingga 0.5. So di mana 0.2, di mana 0.4 nanti? Can you see that? That is the way. Alright, that is the way. If you need to choose the answer, you should roughly know reactant saya tinggi mana, product saya tinggi mana. Okay, we started off with our product, we started off with our reactant yang turun dulu of course. My reactant over here is SO3. SO3, I started off with 0.5 going down to 0.076. So you need to judge what is your 0.076. 0.5 ke atas, 0.076 duduk paling bawah. Sebab dia adalah nombor yang kedua paling kecil. Okay. And then, cara yang senang, still terbiasa ajar cara yang kamu kena jawab subjektif. Saya suka kalau soalan ni keluar dulu sebagai soalan subjektif. Senang dapat markah. So, we are going to use a ruler, put down a line, a dashes line of course. We are going to put a dash line. Okay. Kenapa dash line? Sebab your graph akan turun daripada 0.5 sehingga 0.076. Sentuh titik ni, sentuh yang dia orang ulat, lepas tu baru jadi flat. Nampak? Senang. Okay, easy. And then as always sayang, label dia siapa? SO3. Tak apa, saya tak ambil dah kot kelas ni, saya dapat jangan risau. Tak ambil kot. Han sanggup ke duduk dengan aku satu sen lagi? 3 sen lah. Ya. Alright. Can we? That is my reactant. Easy. Okay. So untuk yang lain kita akan repeat. Tetapi untuk yang lain kita akan repeat dan graf dia akan naik. Sebab my SO2 starting from 0. My SO2 starting from 0. Jangan lukis dulu. Sebab saya tak tahu saya nak pergi kat mana lagi. So cari dulu SO2 kosong naik ke mana? Naik ke 0.424. So tengoklah paling tinggi 0.5. So let's say my 0.4 over here. Like I say, dia tak perlu ada skala tapi dia kena logic. Nampak? Okay. And then when you have the 0.424 over there, macam biasa, we will draw this line. Okay. We will just draw a line and then drag all the way until you reach the time equilibrium. Okay. So, daripada kosong, naik daripada kosong, naik sehingga kamu jumpa 0.424. Dia akan naik sehingga titik tu dan selepas titik tu pembaris straight line. That is my SO2. Simple. Boleh buat? Yang duduk kat rumah, any questions so far? That is how I'm waiting. The silence when I'm asking question last time when you were in, online. As always, no one will press the mic and decided to ignore that. It's fine. Dah biasa. That is how sad the when I say any question and everybody silent. That is the silence I got every single day. That's how bad it is. How do you feel just now? Jawab lama tak? Macam tu lah. Alright, you have your oxygen over here. Sama, kosong. Oksigen naik kepada 0.20. So 0.5, separuh jadi 0.25. So turun sikit daripada separuh lah. That is my 0.207. Senang? Okay. Cuma konsep lah kat sini. Saya rasa banyak kepada konsep, banyak kepada kenapa dia kena flat, kenapa dia kena flat pada masa yang sama. That is all the concept of equilibrium. Okay. Sama daripada kosong, dia akan naik. Oh, yang ni sikit, tengok. Oksigen kamu sekarang kurang daripada SO2. Jauh lagi kurang, betul? Oksigen hanya hasilkan 0.207, SO2 dapat 0.4 lebih. So, bila kamu lukis pada permulaan kosong untuk oksigen, kamu kena start rendah daripada SO2. What I mean over here is when you start drawing, this starting point, oksigen kena rendah daripada dia. Sebab rate, kenapa oksigen dapat sikit? Sebab kadar untuk hasilkan oksigen rendah. Okay, so dia mesti kena jauh lagi rendah. Dan macam biasa, selepas kamu sentuh the time equilibrium, the line must be straight and constant because the concentration shall remain unchanged. Boleh? Keluar subjektif, lukis ni paling minimum 3-4 markah. Now, bye-bye. Itulah siapa suruh doakan untuk objektif. Hampa doakan untuk objektif tak? Nak online tapi subjektif. That is quite greedy. That is not quite, that is like super greedy. Alright, to expect the world to live as what you wish. It never goes the way I want it. When I ask the question, nobody answer. You want what? Online but subjective, for God's sake, man, wake up. Alright, any question? No. Then we want to go for the next question and the extra question. Kita record kan? Yeah. Good. David. So the next thing that I want to go for is the KC-KP. Any problem calculating the KC? No. So you have the KC already, right? Therefore, I want the KP now. Class, I want the KP. I don't want the KC answer. I want the KP answer now. What is the formula begins, by the way? KC RT delta. $10 million question. What is your delta N? 1. 1. Yes. Zero one. Zero one. Kawan kamu yang tak tahu 50. Yes. Okay. Oh, okay. I feel bad when I heard that one. Alright. Saya tak check kot KC kamu sebab kalau KP kamu betul, then you should have it. You should have your KC correct lah, I suppose, right? So your KP over here kawan kamu dapat kat belakang, Shikin and the gang dapat 250. Yang duduk kat rumah setuju?
Setuju.
Alright. Okay, so you have your 250 over here. Just nak bincang sikit. Look like you know how to use the formula. Kita nak cari KP bila ada KC, we will be using the formula of your KP equals to Kc RT delta N. Agree? First question. This formula coming from? Dalam nota tak ada saya rasa, tapi dalam video saya ada mention in a very few second. I told you that this formula coming from your PV equals to nRT. Dan kenapa saya kata formula ini datang daripada PV equals to nRT? The biggest problem in PV equals to nRT is unit. When this formula coming from PV equals to nRT, therefore this formula also having an issue with the unit. And sebab dia datang daripada PV equals to nRT, therefore the temperature must be in Kelvin. Alright, your pressure, your Kp in ATM, your concentration in molarity. Walaupun kita tahu Kc, Kp tak ada value. Kenapa ada unit? Bukan Miss Wong kata tak ada unit kan? Dia tak ada unit. Tapi partial pressure yang kita masukkan dalam tu ada unit. Betul? Dan kalau Kp yang kamu nak masukkan ke dalam formula ni, partial pressure yang kamu kira ke atas mesti dalam ATM. Okay, kita akan jumpa soalan nanti. Okay, ada soalan dalam tutorial. Okay, itu maksud saya ATM. And disebabkan pressure saya ATM kat sini sayang, therefore the reason why your R must be 0.08206. Tak ada pilihan kat sini. Dalam PV nRT kita ada pilihan, kat sini tak ada pilihan. R mesti adalah 0.08206 because your pressure must be in ATM. Clear? I want delta N. What is delta N? And why delta N equals to 1 just now? Reactant minus product. Ayat pertama, reactant minus product. Yang tak pernah jumpa saya, chicken dia like sangat teruja tengok saya. From the eyes I can read that. Jangan relax aja. Okay, delta N. Takut? Dan you are very lucky sebab kamu hanya rasa takut untuk 3 minggu. Kalau kita start dari awal, kamu kena takut 4 bulan. 4 straight, luckily. Alright, where we are, delta N. The first sentence I have, reactant minus product. Anyone else? Tak jadilah, betul, kekal. Total mole of product. I have a better one, listen. Total mole of product minus total mole of reactant. I only say it's a better one. I didn't say it's a correct one. Yes. Thank you. Alright, duduk diam, tidak suara saya dengar. Luckily, you're sitting very close. Now you know why you need to sit in front. Okay. So, it's the number of mole of the product. And I use the word total. Total number of mole of product in gas minus the total mole of the reactant but only in gas. Kenapa kita hanya ambil kira gas? Very simple formula. So kalau dia keluar dalam exam, this is the place I don't want you to do mistake. Kenapa kita hanya ambil gas? If you read the formula very carefully, the formula is actually to find the Kp. Betul? The initial purpose of the formula sebenarnya kita nak cari Kp. Dan dalam Kp kita hanya ambil kira gas. Apa beza Kp dengan Kc? Kc boleh ambil aqueous, tapi Kp hanya ambil gas. Dan formula ni adalah formula untuk gabungkan diorang. So gabungan antara diorang kita hanya boleh ambil gas. And you know the trick of the question can be as simple as I can make the entire question a lot harder by only changing this to liquid. And it's another story. Betul? So, when you come across this type of question, guys, open up your eyes and bring in your highlighter and highlight that paper. Because after you finish the exam, you are going to recycle the paper. Don't save it. You are not saving the earth anyway. Okay? Use it. Alah, highlighter yang beli kat kau mahal-mahal tu guna. Okay? Happy with that? Perfect. Question? Alright. Sebab tu kamu dapat 3 tolak, saya rasa 3 tolak 2, betul? Sebab tu kamu dapat 1, 3 sebab 2, 1. So kamu dapat 3 di bahagian product. Kamu dapat 2 di bahagian reactant. So 3 tolak 2 kamu dapat 1. Nampak ke? Okay, kalau tak nampak beritahu saya nampak je semua. Anything that I miss out then let me know. Okay? Question? Senang nak guna? Okay. Next question adalah yang ni kita nak bincang guna formula juga. KPKC, alright, we are done with the delta N, we are done with the unit. Okay, let's see this formula. What is the relationship between KC, KP and also temperature? A bit of theory. This formula coming from PV equals to nRT. Tapi bila dia gabung, tiba-tiba pressure hilang, number of mole hilang, volume hilang. Pressure hilang, number of mole dengan volume sebenarnya akan hasilkan concentration. Betul? So, pressure hilang, concentration hilang, tapi yang tinggal temperature. Temperature masuk dalam formula yang ada KC, KP. Dengan kata lain, only only temperature can change KC, KP. Alright, kalau suhu berubah, barulah KC, KP kamu akan berubah. Tapi kalau concentration berubah, dah belajar Le Chatelain principle? Kat Amali? Magi buat apa minggu ni? Okay, dengan siapa ya? So dia tak ajar Le Chatelain. It's okay. It's okay, we'll talk about that later. Where we are. Temperature. Only temperature can change KC, KP. So, when the temperature change, KC, KP value akan berubah. But, if concentration or pressure change, alright, KP, KC akan remain. Alright, benda ni tak akan ubah. Hang ubahlah concentration macam mana, hang ubahlah pressure macam mana, KC, KP takkan ubah. This is a theory that you need to know for your objective. Okay? And if temperature can affect your KC, KP, suhu ubah, KC, KP akan ubah. So the biggest question, dia naik atau turun? Dia directly proportional atau dia inversely proportional? Kita tengok formula sikit. Kalau KP dengan temperature, okay, KP dengan temperature, inversely or directly? Directly. KP akan jadi directly dengan temperature, betul? Kalau KC akan jadi inversely dengan temperature. The conclusion that you need. Okay? And over here, soalan saya, would the KC change if the reaction take place at 573 Kelvin? Another issue dalam soalan objektif ataupun soalan ayat yang kita akan manipulate is, kita tak bagi tahu terus sekarang temperature dia naik atau turun. Kita tak bagi tahu suhu dia naik atau turun. Tapi kamu kena identify suhu tu naik atau turun by looking at the before and after. My before is 473. My after yang dalam soalan is 573. In the other words, temperature increase or decrease? Temperature increase. And question asking for KC. So kalau suhu meningkat, what happened to my KC? KC decrease. Betul? Satu maka konsep. Okay? Nampak? Okay. Question so far? No. Soalan F, ada masalah kah? Soalan F? Soalan F dapat berapa? Ataupun dapat macam mana? 1 per. Okay. We are looking for the KC prime where the equation adalah terbalik. 2SO2 gas tambah dengan O2 gas dapat SO3 gas. Equation terbalik, betul? Yang ni bukan isu apa, yang ni matematik je. Bila pecahan kamu terbalik sebab dia adalah 1 per. Okay? Yang ni ada soalan lain yang kita boleh bincang yang banyak lagi pasal soalan macam ni. So the KC prime akan jadi 1 over KC yang kamu cari tadi. Dapat berapa? 0.1552. Betul? Saya tak kira betul kot. Ya. Yeah. Alright. Any question? No? Okay. So what makes your question 1 until 10 kat sini adalah semua soalan 1 until 11, I think if I'm not mistaken, 1 until 11 or 12 adalah pada equilibrium, di mana I stable tak masuk lagi. Betul? Alright, kita akan tengok banyak lagi soalan esok. Just a quick one. Looking at your question 7, please. A very quick one. I need one thing. I believe you have calculated them, so I need it very, very quickly. I need delta n for every single one of them. Question 7a, can I have delta n?
Sure.
-2. Thank you. Lagi? -1. Apa tak payah tekan mic, kita tanya orang yang kena tekan mic. Alright, Shikin, Putri? Sorry. Putri, soalan C.
-2.
Lauda?
-2.
-1. Okay. TV?
0.
0. Sabila?
0.
0. Why Sabila? I thought it's -1.
Only accounted for gas.
Only accounted for gas. Nampak? So I can change your life by changing that small letter in the question. And that is what happened in your objective later on. Okay? And in this one, because I only have 10 minutes left, in this one, I want to show you something. Soalan A to C saya tak payah buat apa dah. Kira lah. Okay, kira lah. What would be the KP, KC of D and E? Why the same? Because anything to the power of 0 will be equals to 1. Perfect. Betul? Benda ni akan jadi satu teori yang kamu kena tahu, satu mathematic concept yang kamu kena tahu, dan dia sangat berguna bila kamu tahu, especially dalam objektif. It will save a lot of time. Okay? So if your delta n equals to 0 over here, mathematic wise, everything that to the power of 0, like Zawani said, tak kisahlah value dia temperature berapa, kuasa kosong. Dia akan jadi 1. So automatically when delta n equals to 0, Kp equals to Kc. And if you know this, you save your time. Okay? Easy? Make sure you know this. Okay? Sebelum ni saya tak bagi conclusion macam ni sebelum ni. Saya akan suruh budak hang kira lah, dan you tell me kenapa dia sama. And majority budak dia orang tak tahu pun kuasa kosong tu 1, dan dia akan kira lah. Hang gelap, cuba kalau aku tak bagi tahu. Hang tekan calculator juga kan? Okay. I have 10 more minutes. Can I have one more question maybe? Do you have class after this? Ada. Then can we go for a question that I think is quite interesting? This one. Oh. Yang lain boleh tanya. Anything. Boleh tanya. Yang ni sebab kita duduk bincang KCKP. So saya nak sambung KCKP saya. Okay. So, one of the past year question. Part of the past year question, tak tahu bila saya tak tahu. Very interesting question. Alright. Look very confusing, but actually very, very simple. At 25 degrees Celsius, water, liquid. The biggest difference between them, dua-dua adalah water, tapi satu liquid, satu wap air. This is a process of your condensation and vaporization. Okay, jadi wap air dan juga jadi liquid. Reach equilibrium according to that. Question asking for Kp and Kc. Vapor pressure is given. Saya nak tanya, vapor pressure yang dia bagi ni sebenarnya adalah partial pressure untuk gas atau liquid? Gas, sebab dia vapor. Betul? Dia vapor. The question stated is vapor. Satu. Kedua, liquid boleh ada tekanan ke? We always talk about pressure and only for gas. Hang kena tahu bahawa benda ni sekarang adalah gas punya. And look at my label. It will be slightly different. Because saya ada dua-dua adalah water. So saya akan label water gas. Okay? Soalan kat sini agak senang untuk Kp. Soalan nampak senang tapi agak tricky. Your Kp equals to the partial pressure of H2O gas only. Setuju? Sebab satu lagi liquid. Tak boleh lah kan? Tak payah apa. Setuju? So saya rasa tahun tu ramai student yang akan jawab terus KP equals to 23.8 torr. Betul atau salah? Kenapa salah? Nanti nak guna, nanti punya cerita lah. KP sekarang betul tak? Kalau kamu jawab KP equals to 23.8 torr, kamu akan dapat satu markah di sini. Dia betul di sini. But when the question asking for KC, the problem arises. When the question asking for KC, we will be using this formula. Betul? A quick one, delta N sama dengan?
1.
1, thank you. Alright, yang suara tu thank you. Delta N sama dengan 1, setuju? Okay, masalah wujud kat sini. Kita tak boleh guna torr ke dalam formula. Sebab R kita adalah 0.08206. Betul? That is the problem arise. So, to solve that, your temperature is 25 degrees Celsius. Change it to Kelvin 298.15. I don't know how many million times we talk about this. Your R is a constant of 0.08206. The problem arise adalah KP. This is a special case di mana kamu boleh tukar terus ke menggunakan KP sebab partial pressure dia sama dengan KP. Kalau matematik yang betul adalah kamu kena tukar partial pressure ini, bukan tukar KP. This is the correct technique. Alright? Kamu tukar dia kepada ATM. And 223.8. ATM berapa? 0. Thank you. Betul? Then only you can put into the formula. Simple question. And this is the type of question yang dia boleh keluarkan objektif kamu. Nampak senang? Yang saya yakin orang akan buat careless. Okay? Banyak teori in behind of the formula that you use. The value that you calculate, the delta N sama ada kosong atau, and ramai gila dapat delta N tahun tu bila dia keluar sebagai soalan. So semua orang, senang gila dia orang jawab. KP dapat 23.8 torr, KC dapat 23.8 torr. Kalau tak hang. Okay? Alright, and obviously your delta N over here is not 1. Talking a bit about your delta N guys. Tapi delta N ni 1, tak sharp. Tak ada apalah, just mathematic wise, bila kamu tekan calculator, delta N adalah untuk kedua-dua orang. Issue tekan calculator is another problem that I don't know when I can solve it. And there's vaccine for COVID. What vaccine do I have for your calculator, Carlos? I really mean it. I can make you better, but how can I make you not having mistake? For 30 questions in 1.5 hours. Do you have any idea how tough the question will be? I don't know how tough the question will be, to be honest. Because it's the very first year that we have final that, and we are having only objective final. Before this, we do have paper 1, paper 2. Betul? All right, we have paper 1, paper 2, and your paper 1 is already tough. 30 questions, 1 hour, but that 30 question is only C1, C2. Calculation straightforward, definition, simple theory. C3, C4 is another level of question. Okay? The question that we've been doing. And you have extra 30 minutes only. Kalau lulus sini kamu pun tak cukup masa. I don't know at what quality of question that we are talking about because it's our very first year. I don't know how tough will it be. I mean, I'm looking forward for an easy one, but you know, we always prepare for the worst. And like I said, I can make you so good, but I can't make you have no mistake. And right now, you need to be a human. You need to be a superhuman that taking that 4 subject objective paper with no mistake acceptable. Can you do that? Can you do that, guys? All right, we have no space. What, Benjin, you're having, wow. What is your, Benjin, are you putting poster there or what? I miss your fan. The only thing that I know you're there is because your fan is moving. Oh yeah, it's not, now it's good. Yelah, dia on pun sama gang. Forever tak nampak muka penuh. Forever tak ada suara, tak ada expression. Banjir ada suara jugalah. Okay, sorry Banjir. And I mean it. We have 2 more weeks and we have no space of mistake. Okay, you need to be